Okay, I think I did a really bad job preparing you for the B3 test. So I'm sorry about that. We're still going to have the test tomorrow. And this is just a quick review video on B3. So question 1 on the test, it is actually going to be the same as or not the same, but a similar question to the practice test. So we're trying to find the exact value of sine 7 pi over 12. So right here, the first question on the test is going to be like a compound angle formula question, where you're trying to find an exact value, but this isn't part of our special triangle, 7 pi over 12. So we're trying to write this as an addition of pi over 3, pi over 6, or pi over 4. So we're just trying to figure out, like, okay, what two things would add up to give us that? Because these are all of our special triangles. So let's just review special triangles. We got pi over 3, pi over 6, root 3, 1, 2. And then we also have pi over 4. Oops, that's pi over 4, pi over 4. 1, 1, root 2. So there are two special triangles. So we're just going to take sine 7 pi over 12, and we're going to write it as an addition or subtraction of two angles. And it'd be nice if the two angles were special triangle angles. And it turns out if we just add pi over 3 to pi over 4, that can equal 7 pi over 12. And in case you don't see that off the bat, change those denominators to both be 12, which means I've multiplied this guy by 4 and I've multiplied this one by 3. So this becomes 4 pi over 12 and 3 pi over 12 equals 7 pi over 12. Okay. So now that we figured out what it would equal, we're going to use our compound angle formula to say sine of pi over 3 times cos of pi over 4 plus sine pi over 4 equal to sine 7 pi over 12. And then all we're going to do is use our special triangles over here, figure out, okay, sine pi over 3 is equal to opposite over hypotenuse, so that would be root 3 over 2. And I'm going to multiply that to cos pi over 4, which is opposite over, or adjacent over hypotenuse, so 1 over root 2. Then I'm going to add to cos pi over 3, which is adjacent over hypotenuse, so a half, and sine pi over 4, which is okay, and then just going to move this other thing down a little bit. I'm just going to multiply them. So root 3 times 1 would be root 3, and 2 times root 2 would just be 2 root 2, plus 1 times 1 is 1, 2 times root 2 is 2 root 2, and then if I just add my numerators, I get 1 plus root 3, and my denominator is 2 root 2. And this is a totally acceptable answer. If I want to take it one step farther, I'm going to rationalize my denominator. So I'm going to multiply the top and bottom of the fraction by root 2. So I'm going to multiply the top by root 2 and the bottom by root 2. Get rid of the radical from my denominator, which will leave me with, if I expand my top brackets, will leave me with root 2 plus root 6 over 2 times root 2 would just be 2, so 2 times 2 would be 4. So this would be my final answer. So this one's the best answer, and this one's like a not too bad. Okay, so that's the first one. So for the first question on the test, I would just give you some sine of something or cos of something, where you would have to express it as a combination of two angles that are special triangles. Okay, second question on the test is trig identities. So it's where you have to prove a trig identity, and it will say prove. So you're going to either pick the left side or the right side to work with. So I'm going to pick the right side because there's a bracket here. So I always like to pick the side with the bracket. And I'm just going to go right off the bat and multiply out my bracket to get rid of it. So I'm going to do sine x, cos x, tan x for my first set. So that's that times that. Minus, then I'm going to multiply by cotangent. So it's going to be sine x, cos x, cotangent x. And now I'm just going to go ahead and change all my tans and cotangents to sine x over cos x. And I'm going to switch my cotangent to cos x over sine x. So I'm just using my two quotient identities, which is awesome because then those cancel out and those cancel out. So I'm just left with sine x times sine x, which is sine squared x, minus cos x, which is cos squared x. And then I can see on my left side, all I have are coses. So I kind of want to get rid of this sine. So from my Pythagorean identity, I know sine squared x plus cos squared x is equal to 1. So if I isolate sine and move that to the other side, I get sine squared x equals 1 minus cos squared x. So I'm going to sub in 1 minus cos squared x minus cos squared x. And then if I combine these like terms, negative cos squared x minus cos squared x is 2. Negative 2 cos squared x is. My left side is equal to my right side. Okay, and the final question on the test is a factoring question. So I'll show you two examples. So the first one is a factoring one here. I can tell it's factoring right away because I've got two sine x's and one of them squared. So right away I know, oh, I'm going to have to factor it. And it's either just going to be a simple factoring one or a complex trinomial. So I'm just going to do a little side here. And I'm going to write this as 2x squared minus 5x plus 3 equals 0. I'm just going to ignore my sign for a minute. And I'm going to factor this. So it's a complex trinomial. So I'm looking for two numbers that multiply to 6 and add to negative 5. So the numbers that work, I think, are going to be negative 2 and negative 3. Because negative 2 times negative 3 is 6, and negative 2 minus 3 is negative 5. So I'm actually going to replace the middle term with those numbers. So I'm going to go 2x squared minus 2x minus 3x plus 3 equals 0. And then I'm going to split my equation in half, and I'm going to factor it. So I'm going to factor out a 2x, which would leave me with just an x minus 1 from these two. I'm going to bring down that minus sign, and then I'm going to factor out a 3, which would leave me with just an x from here and a minus 1, because negative and a negative make that a positive. And good thing my brackets are the same, because that's what I wanted. So x minus 1, I'm going to take that out, and then that leaves me with 2x minus 3 equals 0. And then I'm actually going to sub it back over here, and I'm going to put it in front of the x's. So my bracket's actually going to become sine x minus 1 and 2 sine x minus 3 equals 0. And then I'm just going to set each bracket equal to 0. So sine x equals 1, and 2 sine x equals 3. I'm going to divide by 2 to get rid of the 2, so sine x is equal to 3 over 2. Okay, so right away, I can ignore this guy, because sine of x is not greater than 1. So I have the sine curve. This is 1 close to negative 1, so this is 1.5. So there are no solutions for that. No solution. And then I'm going to take out this guy, sine x equals 1 here. So if we're just looking at the rate of the interval from 0 to 2 pi, I'm going to get that value. And I personally know that that value is going to occur right at pi over 2. If you're not sure how, I know the graph of pi over 2 is at 1. But another way to think about it is if you have your unit circle, you know your y-coordinate is always equal to sine x, or maybe we'll call that sine theta. It's less confusing. So this one question here, see why this value is 1. So that's like right on the y-axis of 1. And I know this value is pi over 2, this is pi, this is 3 pi over 2, and this is 0 and 2 pi. So I know my answer is pi over 2, or 90 degrees. And that's the answer to the question. The other kind of questions I could give you would just be a straight solving one, where I just tell you sine of x equals like 1 over root 2. And you would just have to go through and say, okay, so sine of x equals 1 over root 2. So I know that can happen in quadrant 1 or quadrant 2 because this value is positive. The only way I'm getting a positive sine ratio, okay, sorry, so quadrant 1 or 2, that's where all of the ratios are positive and sine is positive, so it's not going to happen down here. And since I know sine is opposite over hypotenuse, or y over r, I know those values are 1 and root 2. So right away I know this angle is pi over 4 for my special triangles. So I know the answer to this question is going to be pi over 4, but then there's another ratio I need. So this angle gives me the first one, check. And then I need, from my initial arm over to my terminal arm, I need to know this angle here. So I know my related angle here is pi over 4. But what would be this big angle here? So I know to get that angle, I'm going to have to take pi, which is the whole way to here, pi, and subtract pi over 4. So that's like saying 4 pi over 4 minus pi over 4, so I get 3 pi over 4 as my other answer. So there we go. I get 2 values, which makes sense. Because if we look at the sine curve, it looks like we're going to have 2 values, like here and here for 1 over root 2. So we should have 2 values, all happening before pi. Okay, and then finally, the other kind of question, which we actually haven't done that much of, so probably won't give it to you on the test, but say I give you like an equation like this. 3 times tan x plus 1 equals 2. Okay, so we're going to isolate tan. So I'm going to divide both sides by 3. So tan x plus 1 equals 2 over 3. Then I'm going to move the 1 over. So tan x equals 2 over 3 minus 1. And if I want to subtract those, I'm going to turn that 1 into a 3 over 3. So I end up with tan x is equal to negative 1 over 3. So once we isolate it, tan x equals negative 1 over 3. I know I'm not dealing with special triangles because we don't have a 3 in our special triangle. We only have a root 3. You're not going to get an exact value here. You won't. And if we're trying to solve it for the interval between 0 and 2 pi, we can think about it in terms of this guy, CAST. So it turns out our tan ratio is negative. So we don't want it to occur here because it'll be positive and it'll be positive here. So actually we're only going to get 2 answers. So we're going to have a here and here because we know tan will be negative, which makes sense because tan is opposite over adjacent, or y over x. So I know this is going to be 1, this is going to be negative 3, it's going to be 3, this is going to be negative 1. Because these are the related angles that I'm talking about. But the angles that I actually want to find are this angle and then this angle. So since I'm not using any special triangles, I really don't have a choice. I kind of have to just use my calculator and do tan of negative 1, like the negative inverse tan of negative 1 over 3. Okay, so if I punch that into a calculator, you know what? Don't worry about that negative sign there. The value that it gives you, it's going to punch out a negative 18, but we're just going to take that for 18 degrees. So the value it punches out, it actually tells you just what the related angles are. So these little guys in here are actually 18 degrees. Okay. So now I actually just have to figure out, okay, well, what would this giant angle be here? Because 18 is actually not my answer. Like, we actually don't want, that's our related angle. That's the one that's in our triangles. So if we actually wanted to find out what this angle was, and get 162 degrees. So that would be one answer. And then the other answer we'd have to do is 360 minus 18. Which is going to give us 342 degrees. So we actually have 2 answers for this question, 162 and 342. So those are all the kinds of questions that would be on the test tomorrow.